In this lesson, we're going to focus on 7th grade Unit 7, Lesson 7, and we're really going to look at the triangle inequality theorem today. So today's goal is I can show whether or not three side lengths will make a triangle. That's what we're really trying to figure out. So I want to start off today by just exploring. Okay, so we're going to look at this applet today, and we're going to try to figure out if we can make a triangle with three certain sides. Here we're going to start out with side lengths of 3, 3, and 4. Let's pretend they're all in inches. It's just important that they're all the same unit. For a triangle, we can move our sides and see if we can get them to connect. And notice, we play around a little bit, we can get these two sides to connect and create a triangle. So 3, 3, and 4, those are possible side lengths for a triangle. You're going to notice sometimes, though, it doesn't work out. I'm going to try using 2 as a side length, 3, and then 6.5. Here, when we try to connect our sides and see if we can connect them to make a triangle, you're going to notice that they are too short. Okay, so no matter how hard I try here, I just can't get them to connect. So a reason that that happens is because 2 plus 3 is less than 6.5, so it can't actually reach all the way across. Let's try another one. Let's try 2, 4, and 6, just for fun. So in this time, when I try to make 2 and 4 connect, I can do so, but I can only get that to happen if they are right on the line, because 2 plus 4 equals 6. So in this case, we don't actually get a triangle going on here. We just get a straight line. So notice 2 plus 4 equals 6. But if I change this even to something like 4.4 or anything just a little bit bigger, it has enough space that now I'm going to be able to make a triangle. So here's the key idea here is these two short sides have to add up to be bigger than this big side, and then it can connect to make a triangle. It will reach, it won't just be a straight line. Okay, so I want you to think about that idea and see if you think you're going to be able to make a triangle with the following side lengths, if these are all inches. So what do you think? Could you make a triangle with 5, 5, and 1? Well, yes, you could. 5 would be one of the longer sides, and the two short sides, 1 plus 5, that would be bigger than 5. It would be 6, so they'd connect and be able to make a triangle. How about 1, 3, and 17? No, those would not work because 1 and 3 would be so short they'd only add up to 4. They wouldn't reach all the way to the 17 side. And how about 2, 5, and 3? Well, in this case, the two short sides, 2 plus 3, they equal exactly 5. So no, they're going to flatten out to make a straight line. It won't be enough space to make a triangle. Okay, there's one other type of question you're likely to get asked when dealing with the triangle inequality theorem. So you're often given two sides. Two sides of a triangle are 6 centimeters and 4 centimeters. Now you don't know if those are the long ones, the short ones, a medium one, and another. But you're often asked to figure out what the third side has to be in between. So the third side must be longer than, in this case, our third side has to be longer than 2 centimeters. And you can figure that out by subtracting 6 minus 4 to get 2. Because if our third side is 2 centimeters, 2 and 4 would be the short ones. 2 plus 4 equals exactly 6, not enough. It would make a line, not a triangle, so it would need to be bigger than 2 centimeters. How about this? The third side must be shorter than, in this case, the third side has to be shorter than 10 centimeters because if 6 and 4 are our short two sides, they add up to exactly 10. They have to reach beyond it to make it work. So that third side has to be between 2 centimeters and 10 centimeters. Okay, to summarize this, the triangle inequality theorem says that three lengths can make a triangle only if the shortest two sides have a sum that's greater than the longest two sides. In fact, they always say any two sides have to be a sum that's greater than the other side, but this makes it a little simpler. And if you are given two side lengths and need to find the possibilities for the third side, it's got to be larger than their difference, and it has to be smaller than their sum.